Welcome back to the Diagnostic Clinic. I'm your host, and today you are the lead physician. We are stepping right into the high-stakes world of mastering the first and second derivative tests for maxima and minima. Now, this is specifically tailored for the Cambridge Additional Mathematics 0606 syllabus. But honestly, it's absolutely crucial for any of you sitting the 0580, 4024, 4037, and 4040 exams too. So let's dive right into this. We're going to diagnose the exact symptoms of a failing exam answer, and then we're going to prescribe the precise analytical cure to get you those top marks. Think of this explainer as your medical residency in advanced calculus. Because you aren't just learning math today, you're learning how to surgically extract marks from the Cambridge examiners. Let's get started. 15%. Just let that sink in for a second. This single topic, the multi-stage calculus analysis of using first and second derivative tests to actually discriminate between maxima and minima, it accounts for approximately 15% of your total marks in the Additional Mathematics 0606 exam. That is a massive chunk of your final grade wrapped up in just a handful of complex multi-stage questions. This really isn't a topic you can afford to just sort of understand, A 15% weight? That means this is the exact battleground where grade boundaries are won or lost. If you can master this, you are literally building an impenetrable fortress around your target grade. So here is our roadmap for today's explainer. We'll start with the challenge, move into the strategy reveal, go through the transformation, hit the interactive workshop, and wrap up with your final system. All right, Section 1, the challenge. Let's look at exactly where things go wrong for most students. Meet two struggling test takers, Alex and Sam. Honestly, we've all been an Alex or a Sam at some point. Both of them totally know how to differentiate, right? But on exam day, under that ticking clock, they completely miss the mark. Look on the left. Alex suffers from what I call fact overload, basically dumping raw math onto the page without any logical analysis. Alex found the first derivative, set it to 0, found the second derivative, and then just wrote down this chaotic list of numbers. There are derivatives and coordinates everywhere, but absolutely zero explanation. Alex fails to explicitly state whether the point is a maximum or a minimum based on the evidence. It's just math soup. Now, on the right, we have Sam. Sam suffers from rushed execution. Sam read the question, saw find the turning point, found the x-coordinate, and simply stopped. Just put the pen down. Sam completely ignored the command word discriminate, failing to perform the second derivatives test altogether to prove if it was a maximum or a minimum. Both of these approaches totally fail to demonstrate the systematic analysis and evidence-based reasoning that the Cambridge syllabus demands. They leave so many marks on the table just because they don't treat the math as a cohesive argument. Which brings us to Section 2, the strategy reveal. Let's uncover the examiner rubric. To fix these symptoms, we first need to understand that examiners aren't just looking for human calculators. They really aren't. The assessment objectives actually target 3 distinct cognitive domains: knowledge, practical application, and critical analysis. And this brilliantly illustrates what Cambridge defines as true mastery. Mastery is a connected, conceptual understanding transferable to unfamiliar contexts. So what does that actually mean for you in the exam hall? It means you understand why the first derivative represents the gradient of the tangent and why a gradient of 0 indicates a stationary point. It means you understand that the second derivative measures the rate of change of that gradient. That's why a negative second derivative indicates a frowning curve, which is a maximum point. The principal examiner reports explicitly highlight that candidates who reference these cross-topic connections and explain their reasoning achieve significantly higher marks. You've got to connect the dots for them.
Before we continue, subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCS to excel in your Cambridge examinations. Seriously, click that subscribe button and hit the bell icon right now to make sure you have all the best weapons in your exam toolkit. Okay, so how do we actually structure that mathematical reasoning? We use the PEEL framework: point, evidence, explanation, link. You might know this from English literature, but let me tell you, it is a lethal weapon in mathematics. Let's break it down. Point: state your stationary point coordinates right up front. Evidence: show that dy dx equals 0 at this point. Explanation: substitute your x value into the second derivative and show the exact numerical result. Link: explicitly state that because this result is greater than or less than 0, it links back to being a minimum or a maximum. It creates a completely airtight mathematical argument that examiners just love. Let's test your diagnostic skills right now. I'm putting 30 seconds on the mental timer. Which of these two answers properly applies that PEEL framework? Answer A says x equals 3, the second derivative is -4, so it's a maximum. Answer B says the stationary point is at x equals 3. We know this because dy dx equals 0 at this value. Substituting x equals 3 into the second derivative yields -4. Since -4 is less than 0, this confirms the point. 3, 12 is a local maximum. Okay, time's up. If you chose answer B, you are absolutely correct. Nailed it. Answer B leaves literally zero room for examiner doubt. It provides the point, the hard evidence, the mathematical explanation, and that crucial final link right back to the command word.
Moving on to Section 3, the transformation. Let's heal those failing grades.
Here is the exact procedural framework Cambridge candidates must follow. We call it DESEP. Step 1 is deconstruct. Look closely at the command words. Are you being asked to find, show, or discriminate? Step 2 is extract. Pull out the relevant algebraic equation and any specific boundaries for x. Don't bring the whole paragraph with you, just the data you need. Step 3 is select. Choose your analytical framework. Are you using the first derivative test by checking signs on either side, or are you using the second derivative test? Step 4 is execute. Perform the differentiation with crystal clear notation. Please use dy dx. Do not just leave floating equal signs all over the page. And finally, step 5 is present. Deliver your final conclusion using the correct terminology, exactly like we practiced with the PEEL method. Clear notation and precise terminology are your absolute best shields against dropped marks.
Stop scrolling. Subscribe to our YouTube channel Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. We have literally helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing and turn on all notifications so you never miss our weekly exam strategy sessions. Taking just a quick second to subscribe ensures you're constantly building that exam toolkit. All right, let's get back into the clinic. Section 4, the interactive workshop. It's time to put your skills to the test through data scanning, flaw finding, and speed writing. Let's roll up our sleeves. Okay, I need 60 seconds of pure mental focus from you here. Look at this complex data scan. We have x values, the signs of the first derivative, the exact values of the second derivative, and the curve behavior. Now notice exactly what happens when x equals 4. The first derivative is 0, the second derivative is +6. So what does this actually tell us? Well, according to the rules of the second derivative test, if the value is positive, meaning it's greater than 0, the curve is concave up. It literally resembles a smile. Therefore, the point at x equals 4 is a local minimum. Think about it. A smile dips down to a minimum point. Now, if the first derivative changes from positive to negative around a point, and the second derivative is negative, well, that's a frown, so it's a local maximum. Extracting these relationships from tables like this is an absolutely critical skill for the 0606 exams. Listen to this. This isn't just me talking. This is a stark warning extracted directly from the Cambridge Principal Examiner reports. Students lose easy marks by forgetting proper formats and failing to check presentation. Guys, this is the ultimate tragedy of the math exam. You can do the absolute hardest calculus in your head, but if your presentation is flawed, you lose the marks. It's that simple. The examiners specifically note that students frequently evaluate evidence poorly because they fail to identify their own assumptions, or, and this hurts to even say, they drop a negative sign in their second derivative, completely reversing their final conclusion from a maximum to a minimum. Presentation isn't just about having neat handwriting. It is about logical, step-by-step mathematical communication. Let's break down the top 3 mistakes directly from those examiner alerts. Number 1, format omissions. This means writing down an equation without writing dy over dx equals in front of it. If you do that, the examiner has no idea what you've actually found. Number 2, lack of presentation checks. This is when you finish a massively long chain of algebra, you're exhausted, and you just forget to explicitly state the final coordinates of the maximum or minimum point. You did all the work and missed the final landing. Number 3, non-contextual answers. If a question asks for the maximum volume of a box, and you just write x equals 5, max, you haven't actually answered the question in context. You must state the maximum volume occurs when the dimension is 5. Try to spot these specific flaws the very next time you review your own homework. Let's lock this into your brain right now. I have a 30-second speed writing challenge for you. Look at the acronym DESEP from our procedural framework. Deconstruct, extract, select, execute, present. I want you to create your own memory hack, a mnemonic, using those first letters.
Maybe something like, does every student expect perfection? Or do exactly simply every problem? When you are sitting in that exam hall and your mind goes totally blank under the pressure, a strong mnemonic will act like a grappling hook to pull you right back to the proper analytical framework.
Finally, Section 5, the final system. This is your ultimate exam day safety net. Okay, real talk. Let's compare the answer-only strategy versus the method mark strategy. The answer-only approach is incredibly high risk. It's like walking a tightrope without a net. If you try to do the first and second derivatives in your head or on some piece of scrap paper and just write down the final coordinate, if you make one tiny arithmetic error, you get 0 marks. 0. The whole question is blown. However, the method mark strategy is process-driven. By writing out every single step of the PEELL and DESEP frameworks, you are mathematically securing partial marks all the way down the page. Even if your final calculation is slightly off at the very end, the examiner can still award you M marks for your method and B marks for independent correct statements.
The absolutely crucial takeaway here is this: showing you're working saves grades. Senior examiners consistently report that evaluating alternative interpretations and thoroughly showing your analytical process is just as important as the final answer itself. In these multi-stage calculus problems, you might get an M1 mark just for correctly differentiating, another M1 for setting the derivative to 0, and a third M1 for attempting the second derivative. That is literally 3 marks secured before you even arrive at the final tricky accuracy mark. So promise me, never leave a calculus question blank and never, ever hide your working.
Let's distill all of this into your final cheat sheet. Print this in your brain. If you practice these 3 rules consistently, you are virtually guaranteeing top marks. Rule 1, command word decoding. Always, always circle words like discriminate, find, or show the second you open the paper. Rule 2, peel framework application. Make your mathematical arguments point, evidence, explanation, and link. Rule 3, time management matrix. Multi-stage calculus problems are worth a lot of marks, so allocate your time proportionally. Please don't rush through a 15% topic. Give it the time and the step-by-step respect it demands. Students who actively implement these strategies see an average improvement of 2 whole grade boundaries. But that only happens if you practice consistently with our weekly explainer sessions. So, subscribe to our YouTube channel Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. Hit that bell icon right now so you never let another exam strategy pass you by. And before you go, I want to hear from you. Drop a comment below with your target grade for mathematics and the single biggest challenge you are facing right now. Our team responds to every single comment. Keep analyzing, keep practicing, and I will see you in the next masterclass.